All right, here we are. Section 5.6. This is the title of the section is Find Rational Zeros. So, our goal here is to find all real zeros of a polynomial function. And I'd like to bring up the last section, section 5.5. I don't know if you recall from that section when we were finding the zeros or factors of a polynomial, we were always given one zero to start with or one factor. And I kept saying, isn't that nice that somebody told us that first factor, and that allowed us to get going. We did the synthetic division, and then we factored. Usually we would always start with a third order and factor a quadratic. So this section here is to help us figure out how to do that without somebody giving us the first zero. So we have the rational zero theorem. It says if a polynomial, again that notation here is just a fancy way of writing, any x to any power with a leading coefficient. If this polynomial function has integer coefficients, so again, if all the numbers in front of the x terms are just integers, right, so you couldn't have like a 1.2 coefficient, then every rational zero, and again, the word rational means any number that can be written as a ratio, like 1/2, 1/3, right, but not like 1.2568, something that's irrational. And you can figure that out from that it has to follow this form, and it's a ratio of the last coefficient, so the constant term, and any factor of that constant term divided by any factor of the leading coefficient. Yikes, that's a mouthful. Let's do some examples and try to really get to the heart of this. So I made up these two polynomial functions. Fourth order leading coefficient here is 1, right? And so the constant term here, 12. So the way we would say, hey, you could have here are the possible rational roots, rational zeros, right? So the factors of 12 are 1, 2, 3, 4, 6, and 12. So you'd say, hey, I have plus 1 divided by the factors of the leading coefficient, which is also 1. And you'd say that could be plus or minus 2 over the factors, right? Plus or minus 3 over the factors of 1, and 1 is a great leading coefficient, right? Because it's always divided by 1. Like here in this next example, we're going to have to do this all for divided by 1 and then all for divided by 2. Let me just kind of hurry this up. This would be plus or minus 4 over 1, plus or minus 6 over 1, and plus or minus 12 over 1. So if you look at this, it looks like I've listed 6 numbers, but in reality I've listed 12. So of these 12 numbers, 1 or more could be actual zeros for this polynomial function. That's pretty exciting. That it's kind of a code breaker, right? So here 15 has the factors of 1 and 3 and 5 and 15. And then notice that that the number 2 has the factors 1 and 2. So here again we would take, the first factor from 15 plus or minus 1, and we'd divide it by 1, and then we'd also take that same factor of 1 and divide by the other factor of 2. And then we would continue, so we'd take the next factor, plus minus, divide it by the first factor of 2, plus minus 3 over 2. Then we take the next factor, plus or minus 5, divide by the first factor of 2, plus or minus 5, divided by the second factor of 2, and then we'd have 15 over 1 plus minus, and finally plus minus 15 over 2. So again, 1, 2, 3, 4, 5, 6, 7, 8, and there's 2 of each. There'd be 16 possible, one of those 16 possible numbers, or rational numbers would be a zero of this polynomial. So how will we determine which one that is? So let's go through one example here. Here's our third order polynomial function. Again, power 3, we're expecting to find 3 zeros, right? Could be 2 imaginary, but again, we're hoping for 3 real zeros. And so like I was saying earlier in section 5.5, they gave us one of the factors, and that got us going, right? And we did synthetic division, and we found the quadratic, and we factored the quadratic, and we were done. But in this section, we're not given that first factor. We're not given that first zero, so we have to figure it out ourselves. So again, think of the leading coefficient here as 1, this constant term is 10, so the factors of 10 are 1, 10, 2, and 5. Right, so leading coefficient is 1, and the constant term is 10. So our possible roots are plus minus 1 divided by 1, plus minus 2 divided by 1, plus minus 5, 5 divided by 1, plus minus 10 divided by 1. And so here, you need to start testing different zeros. What do I mean? Well, if you look at these, there are 8 numbers here, right? So there's 1, -1, 2, -2, 5, -5, 10, -10. So which number do you want to test? So let's say you decide, I love the number 2. I'm going to pick 2. And again, how did I pick 2? It's random. Typically, we're going to pick easier numbers. I probably should have just picked 1, or I should have picked -1 first, but I love the number 2. So I'm kind of, saying all this in jest, but here we go. So what we do is, if this is, let's stop for a second. Let's say I picked correctly. How will I know that this answer here should be 0, right? If when x is 2, and you plug into the function, y would be 0 for this to be a root, for this to be a 0. Does that make sense? So again, I'm hoping that 0 is the answer, but I'm not sure it is. So let's go through the motion. So we synthetic division here. This is 2. I add this, I get -2. I multiply, I get -4. I add, I get -11. I multiply, I get -22. And right away, you can see this is not going to 0. So, poor decision on my part. Let me get my eraser out. Let me subtract. Let me erase, this. And let me test another. So you should be saying to yourself right now, oh, wow. Exciting that I can, I've got only 8 possible, numbers to pick from, but gosh, this could take a while, right? So you definitely want to just try. And so again, the number 2, that's the number 2, is definitely not a solution. Let's go through, maybe pick an easier. Let's start with 1. So I drop this 1, multiply by 1, add, I get -3. Multiply, I get -3. Add, I get -10. Oh, I'm starting to feel pretty excited. -10, and I get 0. Goose egg. So that means that 1 is a 0. So again, I lucked out big time, right? It only took me 2 out of 8 possible solutions to find one. So that means that x minus 1, and again, I'm hoping you're comfortable with the fact that it's x minus 1, right? If I set this equal to 0, I'd solve for 1, which is a 0. And so what do I do? What goes in here? Again, from section 5.5, these 3 numbers are so important, right? They become the coefficients for the parabola that's left over. And then if you notice, that parabola does factor. And finally, you get your zeros are 1, 5, and -2. Again, spectacular, right? Just a neat little trick here to look at these coefficients, the constant one and the leading one, to come up with possible answers. So it's time for you to try, and you really do need to try this. I know a lot of you probably just kind of blast right through this video. Sorry to say it that way, but this is the time where the more you can put into this video right now, the better you are off coming into class. So again, let's kind of get our game plan here. This is a third order polynomial. We're hoping to find 3 real zeros. You, again, are not told a starting point, so you should look at the number 24 and the number 1 and say, my possible, what are my possible roots? So why don't you start with that and see how it goes. Hit pause, and when you're ready, hit play. Haha, did you try? Come on. Really, hit pause, go back to that last slide, try it one more time, write out all the possible zeros, and when you're ready, really hit play again twice. And we're back. Okay, so listen, you should have come up with these possible zeros. And again, how did I do that? I took all the factors of 24. So you should be looking at going as 1, 2, 3, 4, 5, 6, 7, 8 times 2. There's 16 possible, of these 16 numbers, one of these are going to work. Could be 3 right in here as well. So can you start trying? What does that mean? You should set up synthetic division now. Maybe start with 1, then go to -1, then 2, then -2. Have some kind of system. All right, give it a shot. Oh, here we go, little Dr. Seuss for you. So please, again, set up synthetic. Take your time. It's the only example we're doing in this lecture. And so hit pause again, and when you're ready, hit play, and I'll show you how it worked. And here we go. So I'm just showing you the first number I put in synthetic was 1. So I set up my synthetic division. I went through the division, and you can see that my answer was not going to be 0. Again, it would have been awesome, right? Imagine out of the 16 possibilities, you pick the first one. Chances of that happening aren't the greatest. So again, don't give up. Again, hit pause again. Why don't you try -1, and then try 2, and then -2. All right, here we go. Hit pause, and when you're ready, hit play. There's another one. Did you hit play too early? Have you found the roots? Again, you should. The next slide, you're going to get all 3 answers. So when you think you've got them, hit play. And here we go, final answers. So -2, 3, and -4. How did I do it? Well, +1, I showed you didn't work. I tried -1, it didn't work. Then I tried +2, it didn't work. I was getting frustrated, but again, I'm still on the low end of all the possible numbers. Finally, -2 gave me 0. And then I took the coefficients from the synthetic division. I wrote my quadratic, and it factored. So when I'm done, you should have the -2 works. I set this factor equal to 0. I get 3 as an answer. I set this last factor equal to 0 and get -4 for an answer. Hey, if you really tried this exercise, well done, right? It's really going to make a difference for tomorrow in class. So the last thing I want to show you, and this is totally bonus, you should sit back and just relax. If you've had enough of me, you can stop. But I'd like you to walk through just one problem. Just watch the rest of the video, please. Right, so the last one is when the leading coefficient is 8 and your constant is 3. Here are all the possible rational zeros, right? So again, you should look at this as 16 possibilities. And so this is a pretty interesting line. They say, look, if you were able to get a rough sketch, which again, that's a whole exercise on its own, they kind of eliminated to these possibilities, right? They probably sketched it and said, hey, it looks like there's an answer maybe here and here. Then they started blasting through the synthetic. They found that -3/2, and again, the book is being super nice to itself. Like, it picks the first one and it gets it as a 0. Probably takes a little trial and error. But notice what's left over, right? We started with a 4th order polynomial, so this 8 goes to 8x to the 3rd. Let me switch to the next slide, right? 8x to the 3rd. So now you should sit back and say, I can't factor that like a quadratic. And so you have to do this whole exercise again. And that's why we're just looking at, we're not going to do problems this big, but I thought it'd be nice for you to see it. So they take this polynomial here, this 3rd order, and they start going through all the possible rational roots for this. So it's like a whole nother problem on its own. They don't show you all the work, but they figure out that 1/4 is another solution. So that there's the second factor, right? Here was the first factor of 3/2. And now they've got another factor of, or 0 of 1/4. And finally, you're left with a quadratic, and the quadratic doesn't factor. So you should then say, hey, let's use a quadratic formula. They use a quadratic formula, and there are all 4 of your answers. I mean, the good news is you can do any polynomial this way. Bad news is it takes a lot here. This is a lot of work, and they skipped a bunch of, work in the sense they just they just introduced the fact that they had a graph, and here on the second part, they didn't even show you the synthetic substitution that it took. Hey, well done. Look forward to seeing you in class tomorrow.